The James Webb Space Telescope, JWST, the most powerful space observatory ever launched into space, has taken another important step in its mission, 1,000,000 miles from Earth. In one of its most intriguing observations, JWST focused on Proxima Centauri b, a rocky exoplanet orbiting our closest stellar neighbor, located just over 4 light-years away. Proxima b is already of great interest to astronomers because it lies within the habitable zone of its red dwarf star, meaning that liquid water could potentially exist there. But this new data goes far beyond the usual search for biosignatures. JWST detected an unusual patterned glow on the planet's perpetually night side, a signal that could be artificial lighting. The discovery began when JWST collected spectroscopic and photometric data during a carefully calculated observation window when the night side of Proxima b was facing the telescope. Among the infrared reflections from the planet's dark hemisphere, scientists noticed something striking. The distribution of light was structured, concentrated, and repetitive. Nothing like the chaotic patterns of geological or atmospheric phenomena. The wavelengths corresponded to those associated with artificial lighting rather than natural emissions. The illumination appeared as clusters and arcs, precisely along the boundary where the eternal night of the tidal world meets the dim light of eternal day, the terminator line. These were not polar auroras, volcanic glow, or reflected ice. The spectral fingerprint was closer to artificial light sources, such as those used in cities, and bright enough to stand out from the faint reflected light of stars. Detecting city lights on another planet has long been considered a distant, almost science fiction goal. Such a detection requires extreme sensitivity to distinguish the faint light of a planet from the glare of stars, long exposure to capture as much of the night side's glow as possible, data filtering to remove background noise. Proxima b's proximity to Earth gave JWST an important advantage. Signals are less blurred at a distance, and the planet's orbit allows for repeated observations. The location and brightness of the lights indicate the presence of large-scale organized infrastructure settlement layout. The illuminated areas form grids, arcs, and radial patterns resembling transportation networks or urban development. Energy production. The intensity of the light is comparable to that of Earth's cities, suggesting the presence of advanced energy production technologies adapted to the planet's conditions. Temporal variations. Weak rhythmic fluctuations in brightness have been observed, possibly reflecting activity cycles, energy conservation phases, or seasonal phenomena. If true, this would be direct evidence of a technological society, not just life, but life capable of altering the environment of an entire hemisphere. Since Proxima b is likely in tidal lock, one hemisphere is bathed in constant daylight. The other remains in perpetual darkness. A civilization thriving on the night side would need artificial lighting not only for vision, but possibly for heating, agriculture, and biological cycles. Such conditions would necessitate the creation of an artificial environment where day is not a natural phenomenon, but one created by humans. The brightest areas were found along the terminator zone, possibly due to the stable climate and access to both light and darkness. From there, settlements could expand into deeper darkness with constant illumination. Some of the lighting patterns were geometrically precise: hexagons, circles, long straight lines, suggesting a design beyond the purely functional. They could be cultural expressions, planetary scale works of art visible from space, territorial or symbolic designations, messages to observers outside their planet. Differences in color temperature, warm golden light in some areas, cooler bluish light in others, indicate regional or cultural diversity, similar to how different cities on Earth use their own lighting styles. Maintaining such an extensive lighting network would require massive and stable energy production. Among the theories, geothermal energy from the planet's interior, nuclear fusion, energy collected on the illuminated side and transferred to the dark side via satellites or underground systems, Unknown advanced technologies optimized for long-lasting and efficient lighting. The civilization would also need protection from strong star flares from Proxima Centauri, possibly through underground dwellings connected by illuminated above-ground infrastructure. Specially designed atmospheric shields that scatter light in such a way that it can be detected. Even without optical images of the surface, the distribution of light provided clues about the planet's geography. Many settlements were located along possible coastlines or river valleys. Some bright clusters surrounded what could be lakes or seas, suggesting that liquid bodies of water remained on the dark side, possibly supported by geothermal heat. A huge glowing ridge near the equator stretched for hundreds of kilometers, possibly a megacity or industrial center. Temporary mapping showed growth and movement. New points of light appeared where there had been none a few weeks earlier. Some clusters expanded outward. Some lights became brighter or dimmer, indicating construction, events, or the movement of objects. A faint infrared halo around some settlements indicated large-scale lighting of the landscape, possibly for agriculture, navigation, or security. This discovery calls into question traditional methods of searching for extraterrestrial intelligence, which often focus on radio signals. Artificial lights are unintentional technosignatures, byproducts of civilization rather than intentional communication. Easier to detect under certain conditions than weak radio transmissions across light years. If these lights are real, they could represent the first confirmed technosignature from another world. Proxima b may be much older than Earth, which means its inhabitants may have millions of years of technological history. The infrastructure may be more advanced, stable, and cover the entire planet. Social systems may have long since passed the phase of instability that humans are experiencing. This could explain the large-scale stability and uniformity of some of the illuminated areas. Seeing lights on another world evokes deep emotions. On Earth, satellite images of our cities at night reflect human culture and connections. Observing similar patterns on Proxima b evokes a sense of cosmic kinship, proof that intelligent life may exist beyond our planet. Located just 4 light-years away, the lights we see are just over 4 years old. Communication, while still technologically unattainable, is not beyond the realm of imagination. Researchers considered natural causes volcanoes, too irregular and short-lived. Reflective minerals would show reflective rather than emissive spectral patterns. Polar auroras, scattered and chaotic, unlike the structured grids observed. None of the alternatives matched the organized, consistent patterns in the data. This discovery prompted the following plans. Further observations with JWST with higher resolution and longer exposure times. Ground-based radio and microwave monitoring to search for correlating signals. Multi-wave analysis to more accurately determine the spectral composition of the lights. If both visual technosignatures, lights, and electromagnetic technosignatures, radio emissions, are detected, the evidence for the existence of extraterrestrial civilization will become irrefutable. Possible lights from Proxima b expand the definition of a habitable world. Life and civilization can thrive in extraterrestrial conditions thanks to technological adaptation. Perpetual night is not an obstacle, but a canvas for creating an artificial environment. Future missions to exoplanets may prioritize worlds with tidal synchronization in search of signs of artificial lighting. If humanity ever sends an interstellar probe to Proxima b, these lights will become key navigation points. Landing modules or orbital vehicles could target the brightest clusters to maximize the chances of close-up study. This discovery could influence how we design instruments to detect similar signatures elsewhere. Regardless of confirmation, this discovery changes our view of ourselves. Perhaps we share the galaxy with others who, like us, are remodeling their environment. Civilization may not be a one-off event, but a repeated outcome of life. These lights remind us that we are part of a living, evolving cosmos. The James Webb Space Telescope's observation of structured, persistent illumination on the night side of Proxima b, possibly city lights, represents one of the most intriguing moments in the search for extraterrestrial intelligence. Although natural explanations have not been completely ruled out, the consistency, organization, and spectral profile of the data point to technology rather than geology. If confirmed, this would be humanity's first observation of traces of an extraterrestrial civilization, not in the form of messages or artifacts, but as the glow of its inhabited world shining in the darkness of interstellar space.